Have you ever wondered how an AI like ChatGPT just seems to get what you're saying? The secret? It's not just about knowing a bunch of words, it's about understanding context. And for a long, long time, that was the biggest hurdle for AI. Let's dive in with a super simple example to see what I mean.
All right, take this phrase. Here, the word mole obviously refers to a small furry animal that digs tunnels. Pretty straightforward, right? Okay, now look at this one. And just like that, mole is a specific unit of measurement in chemistry. Same exact word, but a totally different universe of meaning.
And for our third one, now mole is a medical term for a little spot on your skin. 3 sentences, 3 completely different meanings, all from the same 4 letters. So here's the million-dollar question. You've got to understand, to a machine, the starting point for mole, that numerical code, the vector, it's identical in all 3 cases. To the computer, they're the same thing. So how does it figure it all out? Well, the answer to this question literally changed everything in AI. To get why the new way is so brilliant, we first have to talk about the old way of doing things. Before this big breakthrough, AI models, specifically things called recurrent neural networks, or RNNs, had this huge flaw when they tried to understand long sentences. It was called the bottleneck problem. Think about it like this. Imagine I told you to read a whole novel and then summarize the entire thing in just one single sentence. That's kind of what these older models were forced to do. They'd read a sentence, word by word, and try to cram all of its meaning into one final summary vector. Of course, you're going to lose a ton of detail, right? Key ideas from the beginning of the sentence just get lost or forgotten by the time you reach the end. So yeah, the old way was totally sequential, one word at a time, like a train chugging down a track. And that makes it super hard to connect a word at the beginning of a long paragraph with a word at the very end. But attention, it's a total game changer. It lets the model look at the entire sentence all at once, easily connecting words no matter how far apart they are. And that brings us to the big idea, attention. It's a mechanism that's actually inspired by how our own brains work. I mean, think about it. We don't give equal weight to every single thing we see or hear, do we? No, we focus. We pay attention to what's relevant. And AI researchers basically decided to teach machines how to do the same thing. And this is the absolute core of it. You just throw that whole single summary idea out the window. Instead, the model gets to see every single word in the sentence all the time. Its job is to learn how to assign scores, these so-called attention weights, to figure out which words are the most relevant for understanding any other word in that sentence. Okay, so how does this actually work under the hood? It sounds complicated, but the process is actually surprisingly simple once you break it down. Let's walk through a little analogy of what happens inside a single attention head. All right, let's take this sentence for a spin. The goal here is for the model to learn that Fluffy and Blue are connected to Creature. It pulls this off using a system that works a lot like a database lookup, with 3 key parts. Okay, first up, every single word creates something called a query. Think of it like a question or a search request. The word creature, since it's a noun, might send out a query that's basically asking, hey, any adjectives out there that are describing me? Next, every word also puts out a key. The key is kind of like a sticky note or a label. It advertises what the word is all about. So a word like fluffy creates a key that says, yep, I'm an adjective right here, and this is the kind of info I have to offer. And the third piece of the puzzle is the value. The value is the good stuff. It's the actual meaning, the information that the word is ready to share if a good match is found. So the value for fluffy contains the actual meaning of what it is to be fluffy. So here's how the magic happens in 4 basic steps. First, score. The query from Creature goes out and checks against every other word's key to see how well they match up. Then, normalize. Those raw scores get squeezed into attention weights, a number between 0 and 1. So Fluffy and Blue get high scores, and a word like roamed gets a really low one. Next, weight and sum. The model uses those weights to create a new, blended piece of information from all the different value vectors. And finally, update. That new, context-rich information is used to update the original understanding of the word creature. And just like that, the word is no longer generic. It's now understood in context as a fluffy blue creature. But wait, it gets even better. Here's the real kicker. See, a model doesn't just do this one time. The real superpower of attention comes from doing this over and over and over again, all in parallel.
So let's take a big model, something like GPT-3. We're not talking about just one of these attention heads doing all the work. We're talking about 96 of them, all working at the exact same time in just a single layer of the network. 96.
So what in the world do 96 heads even do? Well, this is where the genius of it comes in. Each head learns to be a specialist. So you'll have one head that gets really good at grammar, connecting subjects to verbs. Another one is basically a thesaurus, figuring out synonyms. A third one is like a little trivia expert, connecting Paris to the Eiffel Tower. And maybe another one is just tracking the emotional vibe of the text. Together, they build this incredibly rich, multi-layered understanding of language.
And here's why that's so important. Because all 96 of those heads can do their job at the exact same time. They're not waiting in line. The whole system is ridiculously efficient. It's basically tailor-made for how modern GPUs work, and that is what let these models scale up to the massive sizes we see today.
So this whole idea, this massively parallel attention mechanism, it wasn't just some small upgrade. It became the bedrock for a totally new way of building AI. And this led directly to all the crazy stuff we're seeing now.
And man, did this idea evolve fast. It all started back in 2014, really as just a patch to fix those old clunky translation models. Then, by 2016, we get this idea of self-attention, where words in the same sentence can pay attention to each other. And then, bam, 2017, the big one. A paper drops that basically throws out the old rulebook, building a new model using nothing but self-attention. They called it the Transformer.
And this is why all of this matters to you right now. That Transformer architecture, it's the engine running under the hood of pretty much every big generative AI you've heard of. ChatGPT, Google's models, its core ideas are even used in models that generate images from text. It all comes back to this one powerful idea.
The title of that 2017 paper, Attention is All You Need, was super bold. I mean, it was almost arrogant, right? But here's the thing. They were basically right. By teaching machines to do more than just read words, by teaching them to weigh their importance, we gave them the key to understanding context. We taught them how to pay attention. And honestly, that changed absolutely everything.